In this video, we are going to talk about the assay in Aspen Hysis. Assay is like the component list, but it's more advanced because, as we know, Aspen Hysis is about oil and gas industry. In the gas, you can have simple components like methane, ethane, propane, and so on. But when it comes to oil refinery, we have a more complicated or more complex of a components together. To add these components, it's really tough to add them as a component list, so we use the assay. Okay, so here in this case we are going to create a new case, and after this new case, instead of adding the component list and after that we add the fluid package, we are going to add our petroleum assay. So here's the component list, the fluid package. After that we have directly the petroleum assay. So I'm going to choose this petroleum assay, and we have the assay summary. Here we have different sections available. So here we can display all regions, and here we have our default fluid package not mentioned yet. So here to add a petroleum assay, we have the add in the bottom. In the add, we can import from a library, or we can import the petroleum assay or the material that we are going to use from a file, or we can enter it manually. So we have here three options. So at the beginning, we are going to add our first petroleum assay manually. Okay, so from add, I am going to enter or manually enter my petroleum assay. Okay. So here there is no assay compatible with the list added. Actually, I haven't added any list before. So in this case, we are going to choose from this one. So here in this one, we are going to choose from a common data that is already available. So the petroleum assay compound can be up to 850 or 1150. This is in Celsius. This is the temperature in Fahrenheit. We can have a component list for FCC or fluid catalytic cracking or hydrocracking or reforming. So if we have an oil refinery plant and we have our first feed, which is going to an atmospheric distillation, this feed can be presented as a petroleum assay. So I'm going at the beginning to choose assay component with a degree Celsius to until 850 degrees Celsius, and after that I am going to press OK. So I have selected this one. This is really important. This section is really important because if you are familiar with oil refinery, we usually in the atmospheric distillation or vacuum distillation, we have the term cut. So the gasoline could be our cut, or the gasoline itself can have different cuts because it is not one only component. It's a variety of components available in a specific boiling range. So if I have an initial boiling range and a maximum or a final boiling range, so if I'm taking a range between 30 degree and 70 degrees Celsius, this is the 30 is our initial boiling point and the 70 is our final boiling point. This is the range of temperature we have, initial and final, so it is defined as a cut. This cut will have the component in between this range. Okay, so to define, we can have multi-cut properties, or we can have a single stream. You can add the number of cuts that you want to have. So in this case, it's defined by default in Aspen Hysis to be 5. So after that, we can also define our fluid package from here. So this one is basis number 1. Okay, so now we are going to choose that we are having a single stream properties. Okay, if I am adding a single stream, this is a distillation percent. This value is coming from an experiment. If imagine that you have a flask, and inside this flask we have the petroleum sample, and we are increasing the temperature. So as the temperature of 10 degrees Celsius, we don't have any percent of distillate. After that, the evaporation starts, and when the temperature is increasing, we have a 55%, 10%, and 100% means we have already done the distillation to the whole sample. So this percent is represented by another temperature. For the multi-cut properties, we have the cut, we have an initial boiling point and a final boiling point. For the single stream properties over here, we have, this is the TPP, which is the true boiling point, and we have a mass percent over here. So 0% will be distillated at this temperature, which means no evaporation, they are still in the mass balance. For the 5% mass distillated, which means 5% of the mass available in the flask has been distillated, this is a specific temperature. Okay, we can also click at by the mass, and we have another option, like we can define it by volume. So 5 milli from 100 milli is 5% has been distillated. So you can choose whatever you want. In this case, I'm going to stick with the volume because during the experiments, especially the one for the true boiling point, it makes more sense to measure the volume. You can visualize it by your eye. The volume has decreased from something to something, you take the difference, this is the percent that you are decreasing. Okay, so in this case we have 5, 10, 30 and so on. So here I am going to insert some tables because I am having different values. Like I'm going now to insert the values over here. So the distillation, I have the value for 0. After that I have 4, 9, after 9 I have 14, after 14 20, after 20 I have 30, after that I measure for 40% distill, 50, 60, and okay, because here we are done, we need to insert another row. So I'm selecting my last row and I'm going to right click on it, and I'm going to insert another distillation percent. Okay, so this one should be, actually this one is a 60 over here. Oh, okay, it's already exists, so I need to remove this one. This one should be deleted. You can use delete from the keyboard. And I am have 60, 70, so I am having another 4, so 1, 2, and I'm going to insert another 2. Okay, so after the 50 I'm having 60, after that 70, 76, and one more, which is 80. So these are the percent of distillations that I'm having. So here this is the temperature, and I'm adding the temperature in Celsius. So for 0% it is reported at negative 12 degrees Celsius. After that we have 32 degrees Celsius, 74, 116, 154, 224, 273, after that 327, 393. Now I'm going to check that I'm at the right point, which is 70% at 450, 400 after that, and 90, and finally at 560, which means my distillation 80% will be removed at 516. Understanding the meaning of these values is really important, because this is coming from an experimental data inside the lab in your plant. Okay, so after adding this information, we can now press OK. Okay, after pressing OK, it will take a while, and here our assay will be uncharacterized. This is our distillation data that we have entered manually. So if you have any problem with the data entry, you can revisit this one. Okay, if we look over here, this is our input summary, and in the input summary you can enter the data like a physical properties that you have. So like this is the sulfur weight percent. This value also is coming from the data analysis. These data are coming from the lab inside your plant. So if your plant have a lab for the analysis, and actually it must have a lab for analysis if you are not outsourcing these values, you are giving a sheet with the data for some experimental data or tests that is done to maybe, for example, define how much sulfur by weight percent is present in your sample. So each information that you have in the report, you can add it here inside Aspen HYSYS from the input summary. So you can add your information here. Like here, the cut yield by volume percent is 100%. Okay. So in the input summary, you can add, we have now information about the liquid density, the standard liquid density, and this value is given in the API. So the API, so I'm given the API. So at the beginning we have the density equal to 17 as API. Okay, so and the sulfur percent over here is 2.7, so this one is 2.715. okay, so this is the sulfur by weight percent, which means if I have 100 kilogram, 2.7 of these kilograms will be sulfur. For the density over here, it's in kilogram per meter cube, and usually in the oil and gas industry you use the API unit. So to change this unit to represent the density, we are going to double click on it, and we have the physical property over here, which is the standard liquid density, and we are going to change the unit over here. We have different units available. I am going to select the API and press OK from here, from the green line. So now our density will be displayed in API, and its value is 17 API. So now I have defined this information. Next video we are going to add some pure components.